Hello viewers, my name is Ndubisi Emmanuel. Welcome to my channel Ndubisi Online Maths and Physics. In this video, we are going to discuss the topic on physics, units and measurements. Units and measurements. Units and measurements. We have been on this topic for a while. So we are going to continue from. We are still on dimension. Dimension of physical quantities. Dimension of physical quantities. Now, in our last video, we spoke about acceleration, right? Yes. So there are some things that we need to know that is guiding us in dimension. Mass is what? Kilogram. And kilogram is what? Whenever you see kilogram, you represent it what? Capital M. Length. Length in meter. So whenever you see something like this, represent it what? Capital M. Then time in seconds. Time in seconds. Whenever you see something like this, T. So this is what is guiding us as a guideline in dimension of physical quantities. Now let's continue. I think it's number 5 now. Yes, if I'm not mistaken. We continue from force. Now, for you to know the dimension of force, I told us that we have to know the what? The formula. What is the formula for force? Formula for force is mass times acceleration. Is that clear? Mass times acceleration. Now, we all know that mass is in kilogram. Then acceleration is meter. Meter per what? Per second square. Yes. Mass is in kilogram. Acceleration is in meter per second square. In our last video, we talked about acceleration and also derived quantities and their units. We discussed acceleration there. So acceleration is meter per second square. Mass is what? Kilogram. So when you multiply this, you have kilogram meter per second square. So this is the unit of force. So using this, you can be able to find the dimension of what? Force. Let's go. Let's find the dimension for force using the unit of what? Of force. Kilogram meter per what? Second square. Now, how can we find the unit dimension for force? Now, whether you see kilogram, represent it with what? Capital M. Whenever you see M, meter, you have to represent it with what? Capital M. S with what? Capital T. So kilogram is M. M. Meter is length L. T is what? S is what? T, right? T. This minus 2, just put it there again. So this is the dimension of force. So MLT raised to power what? Minus 2. Or ML per what? T square. So this is the dimension of what? Force. Let's talk about number 6, work or energy. Dimension of work or energy. What is the formula for work? Force times distance, right? Yes. Now, don't forget that force is what? Kilogram meter per what? Second square. Is that clear now? Kilogram meter per what? Second square. Times distance is what? Meter. Don't forget that. Distance is what? Meter. So when you multiply this, the unit of work become kilogram, because we have M here. M times M. M square. Then repeat S which is what? Minus 2. This is the unit of work. This is the unit of work. Now, from the unit of work, we can find the dimension. Then, how can we find the dimension for work using its unit? Very simple. Kilogram is what? M. So this is work. Don't forget that. So kilogram is what? M, right? M Meter is in what? Length. L square. Second is what? Time. T raised to the power minus 2. This is what? Dimension for work. Is that clear now? This is the dimension for work. In our next video, we talk about power, momentum, and pressure. We are going to summarize everything in our next video, so that we can move to measurement. I'm just doing it like this so that you can be able to capture something. So this is the what? Dimension for work. Through the unit of work, we know the dimension. L square T raised to the power minus 2. That is the dimension for work. If you really enjoyed this video, please do well to like, comment, and share. Also subscribe for more videos so that you'll be able to see our video when we post it. Thank you. God bless you.